What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into CloudWatch, CloudTrail, and monitoring data pipelines. Let's get into it. What if a single misconfigured log group was quietly draining $400 a year from your Amazon Web Services account, and you had no idea? That's a real story we'll come back to in a minute. By the end of this video, you'll know exactly which monitoring service answers which question, whether you're hunting down a cost leak, diagnosing a stalled pipeline, or proving who touched a sensitive bucket. These services also show up across the operations and support domain on the Data Engineer Associate exam, so the same mental models pay off twice. Here's a story that plays out in almost every Amazon Web Services account. A team deploys a Lambda function, traffic ramps up, and nobody notices that the log group is set to never expire. A year later, that single function is burning $415 a year just on log storage. The fix is one command, setting a 30-day retention policy, and the bill drops to $18. That's a 95% cut from a single API call. Monitoring and cost are the same conversation, and this video shows you why. The cleanest way to keep these two straight is an analogy. CloudWatch is the fitness tracker on your wrist. It shows your heart rate, your steps, your stress level, and it buzzes when something crosses a threshold. That's metrics, logs, and alarms, operational health in real time. CloudTrail is the security camera in the room. It doesn't care about your vitals. It records who walked in, what they touched, and when they left. That's identity, a PI action, timestamp, and source IP. When a question asks how is it performing, you're in CloudWatch. When a question asks who did what, you're in CloudTrail. This is the alerting chain you need to memorize because it shows up over and over again in exam scenarios. Picture a typical nightly glue job. Something breaks at 3 in the morning. The glue job fails, which pushes a failure metric into CloudWatch. That metric crosses an alarm threshold of greater than 0. The alarm fires and it sends a message to an SNS topic. From there, SNS fans out to whoever needs to know: email, Lambda, SQS, PagerDuty. That's the whole chain. Glue, metric, alarm, SNS, humans. Every Amazon Web Services service that emits logs writes to its own log group. Lambda writes to /Amazon Web Services /Lambda/my-FN. Glue writes to two separate groups. /Amazon Web Services -glue/jobs/output for normal output, and /Amazon Web Services -glue/jobs/error for Spark stack traces. Retention is set per log group, not per stream, and the range goes from 1 day to 10 years. The default is never expire, which is the #1 silent cost leak in CloudWatch. FinOps audits consistently find that a single put retention policy call cuts log spend by 90% or more on the affected groups. Every team that just deploys and forgets ends up paying to store log data forever. Set retention on day 1. Here's how Amazon Web Services describes the query model for CloudWatch Logs Insights. Logs Insights queries offer a purpose-built pipeline of commands separated by the pipe character, with data flowing from left to right. That left-to-right pipeline is the entire mental model. Each pipe is a stage that hands its output to the next stage. Once you internalize that, the syntax stops looking weird and starts looking like a Unix shell. Let's read this query the way Logs Insights reads it, from left to right. The first stage, fields, selects the columns we care about. The names starting with the @ sign are built-ins that Logs Insights adds to every log entry, the timestamp, message, and log stream fields, which you can see in the code on screen. The second stage, filter, throws away every message that doesn't contain the word error. The third stage, stats, counts those errors in 5-minute buckets. Then sort orders the buckets by time, newest first, and limit caps the result at 20 rows. 5 stages, 1 pipeline, 1 investigation. Think of an insights query like a factory conveyor belt. Each pipe is a worker station. The first station pulls raw boxes off the truck, the next throws away the broken ones, the next counts them, and the last ships only the top 20. Now ask yourself, where should the trash-throwing worker stand? Up front, obviously. If you put filter after stats, you're forcing the counter to process millions of log lines you don't even care about. Filter early, and the rest of the pipeline gets cheap and fast. Two features with almost identical names, completely different jobs. On the left, Container Insights collects infrastructure metrics from your containers, CPU, memory, disk, network, restart counts. It works across ECS, EKS, Fargate, and self-managed Kubernetes. If you're staring at pod restart counts or container memory pressure, you're in Container Insights. On the right, Application Insights is a machine learning feature that auto-detects anomalies across an application stack, originally built for .NET and Java workloads. It tells you something is wrong somewhere in your multi-tier app and points at the probable cause. It does not give you raw container metrics. The decision rule is simple: if you need infrastructure numbers, reach for Container Insights. If you need to diagnose multi-tier application behavior, reach for Application Insights. Contributor Insights is the third member of the family, and it has one very specific job. It identifies the top-end contributors to a metric. Think of a bouncer with a clipboard at a busy nightclub. He's not writing down every drink order, he's writing down the 5 loudest customers causing the trouble. The canonical use case is finding DynamoDB hot partitions. Remember from the DynamoDB episode, when one partition key gets hammered while the rest of the table sits idle. DynamoDB Contributor Insights surfaces the most accessed and most throttled partition keys, giving you instant visibility into which key is causing the hot partition problem. Here are all 4 Insights features on one screen. Container Insights gives you infrastructure metrics for ECS, EKS, and Fargate containers. Application Insights uses machine learning to spot anomalies across .NET and Java application stacks. Contributor Insights surfaces the top-end contributors to a metric, classically DynamoDB hot partition keys. And CloudWatch Logs Insights is the pipe-based query language for searching log groups. Same CloudWatch brand, 4 completely different tools. Match the symptom to the tool, and you'll always pick the right one. This single sentence from the CloudTrail user guide is one of the highest yield facts in the entire operations domain. By default, Trails and event data stores log management events, but not data events, network activity events, or insights events. Read that twice. Data events are off by default. So if a scenario says we need to log every S3 object access and the trail was just created with defaults, the answer is that those events are not being captured at all. Here's an analogy that makes this stick. Management events are the building's front door log, who unlocked which office, create bucket, attach role policy, console login. The building tracks the doors by default and the first copy is free. Data events are the log of every photocopy made inside each office. S3 get object, Lambda invoke, DynamoDB put item. You pay extra to put a counter on every photocopier, which is why they're off by default. The rule to internalize is this: data events must be explicitly enabled anytime you need visibility into object-level operations like reads of a sensitive S3 bucket. CloudTrail gives you 3 ways to look at your audit data. Event history is the console view limited to 90 days, a single region, and no SQL. CloudTrail to S3 plus Athena, which we covered in the Athena episode, gives you cheap analytics, but you're managing the S3 lifecycle and glue crawlers yourself. CloudTrail Lake is the managed option. It's an immutable event data store. You query it with SQL directly, and retention goes up to 10 years. When you need SQL on years of immutable API history for compliance, CloudTrail Lake is the right tool. It's managed, queryable, and tamper-proof by design. Let's troubleshoot a glue job. When you see out-of-memory errors in CloudWatch, switch to R.1x or R.2x memory-optimized workers before you bump the DPU count. R-type workers double the memory of the equivalent G-type. SparkStack traces land in the /Amazon Web Services -glue/jobs/error log group, while normal output goes to /output. For sizing, G.1x is 1 DPU, which equals 4 vCPU and 16 gigabytes of memory. G.2x, G.4x, and G.8x scale linearly from there. And here's the gotcha: if your data is skewed, meaning a few partitions hold most of the rows, adding more DPS does nothing. Repartition first, then scale, or those extra workers just sit idle while one straggler finishes the job. Glue job bookmarks fail silently. No error, no warning, just yesterday's data getting reprocessed. 5 conditions must all be true. 1. The bookmark itself is enabled on the job. 2. You use the dynamic frame API. Spark data frames will not work. 3. Every read and write passes a transformation_CTX parameter so Glue can track per source state. 4. Your script calls job.init and job.commit. And 5. Max concurrency is set to 1 because concurrent runs confuse the timestamp tracking. Miss any one of those and bookmarks do nothing. In practice, teams most often forget number 3. They switch to data frames for a single transformation, lose the context, and bookmarks quietly stop tracking. The pipeline keeps running, the dashboards keep updating, but the same rows get processed night after night. Here's why IteratorAge is the single most important Kinesis consumer metric, in Amazon Web Services' own words. If this value spikes, data processing from the stream is delayed. And if the IteratorAge gets beyond your retention period, the expired records are permanently lost. That last word, lost, is what makes this a data engineering crisis, not just a latency problem. The default retention is 24 hours, and you can extend it to 365 days, but if your consumer can't catch up, data goes away forever. Picture a sushi conveyor belt where plates expire after 24 hours. IteratorAge is how old the plate in front of the customer right now is. If it's climbing toward 24 hours, the customer can't eat fast enough. Here's the right order of fixes. First, check your partition key distribution. Skew is the most common root cause. Second, raise the lambda parallelization factor. That's free to change, and it lets up to 10 lambdas run per shard concurrently. Third, if ingress is genuinely saturated, add shards. Remember, parallelization is free, but shards have linear cost. Fourth, if each consumer needs its own dedicated throughput, enhanced fan-out gives every registered consumer its own 2 megabytes per second read pipe per shard. Before we leave Glue, one cost lever worth knowing. GlueFlex cuts the cost of non-urgent batch workloads by up to 34% with a single parameter change. The trade-off is variable start time like flying standby. Perfect for a nightly job with a 6 a.m. deadline, terrible for a same-day deliverable. Hold on to that number, we're about to see it next to the other big monitoring cost lever. Here are the 2 monitoring side cost levers that pay off the fastest. First, GlueFlex takes 34% off non-urgent batch jobs with a single parameter flip. Second, a CloudWatch Logs retention policy typically cuts log group spend by around 95%. That's exactly what fixed the $415 Lambda log group we opened the video with. 1 API call, problem solved. 2 levers, 2 completely different workload patterns, and both come straight out of the monitoring and operations side of the platform. Quick connection back to monitoring. The reason CloudWatch metrics matter so much is that they tell you which compute pattern you actually have. If your CloudWatch utilization chart shows long idle gaps, bursty, dev test, 9 to 5, serverless or pay-per-second pricing wins because the platform pauses when you do. If the chart is flat and steady 24/7, reserved capacity pays back fast. The decision rule, let the utilization shape pick the billing model. That same logic applies to Redshift serverless versus provisioned, which we covered in detail in the Redshift episode. Rapid cheat sheet pass, trigger word on the left, service on the right. Who audit a PI call, identity, CloudTrail, metric, threshold, alarm, performance, CloudWatch. Top N, hot partition, DynamoDB key skew, contributor insights. Pod CPU, container memory, ECS or EKS, container insights. SQL on years of a PI history, CloudTrail Lake. Rising IteratorAge, parallelization factor, then shards. That's the whole decoder. 7 things to lock in. CloudTrail tells you who did what. CloudWatch tells you how it's performing. Data events are off by default in CloudTrail, so explicitly enable them whenever the scenario mentions S3 object access. Container Insights gives you container metrics. Application Insights does machine learning anomaly detection on application stacks. Contributor Insights surfaces top-end keys, classically for DynamoDB hot partitions. In Logs Insights, always filter early in the pipe chain. Glue bookmarks need all 5. Enabled, dynamic frame, transformation _CTX, init and commit, and max concurrency of 1. Rising IteratorAge gets fixed with parallelization factor first, then shards, never with Lambda reserved concurrency. Remember that Lambda function quietly burning $415 a year. 1 retention policy call fixed it. 1 command per service, 1 mental model per question, that's the whole game here. Now let's see how well you absorbed it with a quick 5-question quiz. Question 1. A security team enables a default CloudTrail trail and asks why they cannot see any S3 getObject API calls in the logs. What is the correct explanation? Is it A, S3 getObject calls are only visible through CloudWatch Logs Insights, not CloudTrail? B, data events are off by default on a CloudTrail trail and must be explicitly enabled. C, getObject calls are only logged for buckets with versioning enabled. Or D, the trail must be configured as a multi-region trail to capture getObject events. Take a moment to think about it. The answer is B, by default, CloudTrail logs management events but not data events. S3 getObject is a data event, so it must be explicitly enabled on the trail, and that's also why it incurs additional cost. The volume is much higher than control plane events. Question 2. A Lambda consumer reading from a Kinesis data stream is showing rising IteratorAge. Partition keys are well distributed and shard ingress is below the limit. What should you change first? Is it A, increase the Lambda reserved concurrency to allow more invocations? B, add more shards to the Kinesis stream? C, raise the Lambda parallelization factor on the event source mapping? Or D, switch the consumer to enhanced fanout? Think it through. The answer is C, when keys are well distributed and ingress is fine. The bottleneck is consumer processing per shard. Raising parallelization factor allows up to 10 concurrent lambdas per shard at no extra cost, with order still preserved per partition key. Reserved concurrency just caps invocations, it doesn't unstick the shard. Question 3. A compliance team needs to run SQL queries across 7 years of a PI audit history with immutable storage to satisfy auditors. Which option fits best? Is it A, query the CloudTrail event history directly from the console? B, send CloudTrail logs to CloudWatch Logs and use Logs Insights? C, send CloudTrail logs to S3 and query with Athena over Parquet? Or D, use CloudTrail Lake with an event data store? Take a moment. The answer is D. CloudTrail Lake is the managed event data store designed for SQL queries on immutable audit history, with retention up to 10 years. Event history only holds 90 days, and the Athena over S3 path lets lifecycle policies delete evidence, which auditors flag. Question 4. An engineering team complains that their Glue ETL jobs bookmark keeps reprocessing yesterday's files. They confirmed bookmarks are enabled. What is the most likely cause? Is it A, the job is using Spark data frames instead of dynamic frames? B, the job retention policy in CloudWatch is set to never expire? C, job bookmarks require Glue version 5.0 or higher? Or D, bookmarks are not supported when reading from S3. Think about the 5-rule checklist. The answer is A, Glue bookmarks only work with the dynamic frame API, not with Spark data frames. They also require transformation _CTX on every read and write, job.init and job.commit calls, and max concurrency of 1. The most common silent failure is using data frames or forgetting transformation _CTX. Question 5. An operations team wants to monitor CPU and memory utilization for pods running in an Amazon EKS cluster. Which CloudWatch feature should they use? Is it A, Application Insights? It auto-detects anomalies across application tiers. B, Container Insights. It collects infrastructure metrics from ECS, EKS, and Fargate. C, Contributor Insights. It tracks the top-end pod consumers of cluster resources. Or D, CloudWatch Logs Insights. Query pod logs to derive CPU and memory. Take your time. The answer is B. Container Insights is the CloudWatch feature for infrastructure metrics like CPU, memory, disk, network, and restart counts from ECS, EKS, and Fargate. Application Insights uses machine learning for application tier anomalies, and Contributor Insights is the top-end tool for things like DynamoDB hotkeys. Different name, different job. And that's a wrap on CloudWatch, CloudTrail, and monitoring data pipelines. If this helped you out, smash that like button and subscribe for more. See you in the next one.